so the last time we were together on Tuesday, we were talking about identities, and I briefly said to you guys, do you want to do a little bit more identities on Thursday? And everybody except one person said yes. So I asked Watobe, and they said, no problem, I can go ahead and go and do this with you. So what I'm going to do today is I'm going to take identities one step further. All right, so I'm just letting you know at the outset, these are difficult questions. So if you're struggling with them, you're supposed to struggle with them, okay? But hopefully I'm going to extend you a little bit, show you things that maybe your teacher didn't get a chance to show you in the classroom. But it is application of the basics. I'm not teaching you anything that you don't already know, and we're still going to be using the same tools that we used before when we solved identity. So splitting the left and right hand side. We can't work with both sides simultaneously because it's not an equation. We need to use the tan identity, our square identity, compound and double angle formulae are important. When we add fractions, we've got to find an LCD. And the last point that we discussed last time, when we are factorizing, we can't cancel terms. We've got to factorize. So we're going to be looking for trinomials, highest common factor, difference of squares, etc., etc. All right, so the question that is on screen at the moment was a homework question. So I asked you guys to go away and go and try this. So I'm going to quickly work through this now myself. And then when I have got to the solution, then you are welcome to come and ask me questions. So just watch it step by step. I'm going to be explaining exactly how we get to the right-hand side. Okay, so left-hand side equals. So what's unusual for us here is the sine 4 theta in the numerator and the cos 4 theta in the denominator. Those are things that we are not used to seeing. Okay, but I'm going to show you now how we're going to deal with that. So let's just write the question down. Sine 4 theta minus sine 2 theta all over cos 4 theta plus cos 2 theta. So sine 4 theta, let's just write it here on the side. Sine 4 theta is a double angle. So what I could do with it is this. Okay, so when I expand that, it's going to expand to 2 sine 2 theta cos 2 theta. All right, so that's where 2 sine 2 theta cos 2 theta minus sine 2 theta comes from in the numerator. As far as your cos 4 theta is concerned, that is also something that you have not seen before. Okay, so now see there's people putting hands up. Can you just let me do the next step, and then I'll give you an opportunity to ask questions. Just give me 1 second, okay? All right. So when it comes to, let's just go and grab this and bring it up here. It's a bit difficult to fit everything on the screen all at the same time. If you have a look at your, sorry. Ugh, what am I doing? Okay. If you have a look at your compound angle formulae, okay, there's only one way in which we can write the sine double angle. That is as 2 sine A cos A, right? So that's where the 2 sine 2 theta cos 2 theta comes from. When it comes to cos 2 theta, there are 3 different ways in which we can write this particular double angle. Because cos 2A, or in this case, cos 4A, is combined with cos 2 theta, the best thing for us to do is not introduce sine theta because that's just going to make it more complicated. The easiest thing for us to do is to introduce this one over here, or to write cos 4 theta using 2 cos squared theta minus 1. Okay, because if I introduce sine theta or sine squared theta, it's just going to make it even more complicated than it already is. All right, by introducing another variable, for want of another word. Okay, so cos for theta is going to be written as 2 cos squared 2 theta minus 1. And then I'm going to bring my plus cos 2 theta down to the next line. Okay, so Sandisiwe, you had a question. Do you want to ask? And Amahle, I know
Um,
you also had a question. Yes, Sandisiwe?
I was to ask on the 4 cos theta, but currently you're explaining it, ma'am, so
Okay,
I'm listening.
all right. So you're listening. Okay, no problem. Amahle, I know you also had a question.
Good evening, ma'am.
Good evening, Amahle.
In terms of the 2 cos squared theta, why could it not be 2 brackets cos squared theta minus 1 brackets again? Close
You mean
brackets,
why?
sorry.
Did you mean why didn't I use brackets?
Yes.
Okay,
Because because wouldn't it just be you'd take out the 2 and then you'd say open bracket 2 cos squared theta minus 1 close bracket.
okay. I can't factorize 2 out of the denominator. Okay, so
Oh, okay.
you can't snatch the 2 off the angle.
Mm-hmm.
Okay, does that make sense to you? You can't snatch the 2 off
Yes.
the angle. Because if you think about it, what does a double angle mean? If you think about it in terms of a graph, what you are doing is that the graph, if you're talking about the graph of cos 2 theta,
Mm-hmm.
you've changed the period of the graph. The graph is now repeating itself every 180 degrees instead of every 360 degrees. So it's not a coefficient.
Oh, okay.
Does that make sense to you? So
Yes, that makes more
I
sense.
can't snatch the 2 off the angle. If it was 2 cos 2 theta, then by all means I could try and take 2 out. I'd still have a problem with the minus 1, but I can't snatch the
Mm.
double off the angle. Okay.
Okay, thank you so much, ma'am.
All right, no problem. So what's nice about this question, and I suppose it's the same thing that's not nice about this question, is this question really it's kind of the exception to the rule without breaking the rules. Every single one of us, when we've been sitting in class and we've been listening to our teachers say to us, when you see sine 2 theta, rewrite it as 2 sine theta cos theta, or when you see cos 2 theta, rewrite it in one of the 3 following ways. With this particular question, we're not going to do that yet. As we look at it right now, in the numerator, there is a highest common factor that we can take out of the numerator. What is that? What is the highest common factor in the numerator? Can anybody tell me? So just the numerator for now. What's the highest common factor? Let's see who's got a hand up. Amahle, I think your hand was up first. Cos 2 theta in the numerator.
Oh,
Gugu,
no,
you
sorry,
correct.
ma'am. That was my
Oh, was
hand
that
up
from
from
earlier?
earlier.
Okay, all
Yes,
right, no
sorry.
problem, no problem, no problem. Okay, so it would be sine 2 theta. That's right. Okay, so those of you that have said sine 2 theta, that is 100% correct. Okay, so we're just talking about the numerator for now. Okay, so we can take out sine 2 theta at the top. What I'm going to do before I do that is I'm going to rearrange the denominator. And the denominator is a trinomial. So let's just write our numerator, sine 2 theta cos 2 theta minus sine 2 theta. And in the denominator, I'm going to keep my 2 cos squared 2 theta at the front. I'm going to put plus cos 2 theta in the middle. And I'm going to put the minus 1 at the end so that it looks like a trinomial. Remember, most of the time, what we're trying to do when we've got terms is we are trying to factorize. Okay, so we want to get it into a form that can be factorized. We either want difference of squares or highest common factor or a trinomial. So now what I'm going to do is I'm going to factorize and I'm going to take sine 2 theta out of the numerator. That's going to leave us with 2 cos 2 theta minus 1. In the denominator, I'm going to factorize the trinomial. So I've got 2 cos 2 theta at the front of the first bracket and cos 2 theta at the front of the second bracket. I've got 1 over here, so I've got to have 1 there and 1 there. I have plus in the middle, so 2 cos 2 theta times 1 would be plus 2 cos 2 theta minus 1 cos 2 theta would give me the plus 1 2 cos theta plus cos 2 theta in the middle. All right. What's nice now that I have factorized, now I can cancel down. Okay, so that means that I can cancel this bracket over here with that bracket over there. All right, so I can't go any lower. So what I'm going to do, you obviously wouldn't do this in your books or in an exam or whatever. I'm going to now start writing next to it. So what do I have left over? In the numerator, I have sine 2 theta. In the denominator, I have cos 2 theta plus 1. Now, remember last time that I was talking to you guys about this, I said we want to get rid of this 1. We want to try and get rid of this 1 that I'm highlighting in pink. So again, let's go and have a look at our double angle formulae for cos 2 theta. What will get rid of the 1? Would cos squared theta minus sine squared theta get rid of the 1? No. Would 2 cos squared theta minus 1 get rid of the 1? Yes. Will 1 minus 2 sine squared theta get rid of the 1? No. Okay, so I'm going to go with the middle option, 2 cos squared theta minus 1. The other thing that I can do is I can now rewrite sine 2 theta in the numerator as 2 sine theta cos theta. So applying my double angle formulae. At the bottom, 2 cos squared theta minus 1, and then I'm going to bring down that plus 1. Okay. Let's get rid of the 1s. So I've got 2 sine theta cos theta over 2 cos squared theta. I no longer have terms, right? There are no more pluses and minuses at the top or at the bottom. So now I don't have to factorize. I can cancel. So 2 divided by 2 is going to leave me with 1. The other thing that I can do is that cos theta and that cos squared theta, that's going to leave me with cos theta left over at the bottom. Right, and now I'm nearly at my answer. So I'm sorry I'm doing this again. Right, what do I have left over at the top? I've got sine theta left over at the top. What do I have left over at the bottom? Cos theta. And now we can apply our tan identity. We know that sine theta over cos theta is tan theta. Okay, and therefore it equals the right-hand side. Okay, so I'm just going to scroll up a little bit so that the whole thing is on the screen. Okay, we're just missing a little bit of the bottom, but I can always move it back down again. Okay, questions. Anybody got any questions? Laura, the most something could be in one of your exams would be 7. Would this be out of 7 marks? Well, let me explain what you get marks for, and then we can take it from there. Okay, so let's use what will jump out nicely. Let's use green. Okay, every time we apply an identity, we get a mark for it. Okay, so In this question, there would have to be a mark for 2 sine 2 theta cos 2 theta, and there would have to be a mark for 2 cos squared 2 theta minus 1. There would be a mark for factorizing. Okay. Often there would be a mark for an accuracy mark for simplifying. So there would probably be a mark there for simplifying. Then over here, again, we have used more identities. So we could have a mark there and a mark there. And then our last mark would be for correctly arriving at, sine, silly pen, would be for arriving at sine theta over cos theta. We're obviously not going to get a mark for tan theta because that was given to us. So how many marks is that? 1, 2, 3, 4, 5, 6, 7. Yes. Okay, there we go. All right. So, Tamia, I hope I pronounced your name correctly. You have a question? Tamia, you're welcome to unmute and speak. Okay, Palesa, I'm going to answer you now. Tamia, I'm going to answer Palesa now. If you do want to ask a question, you're welcome to put your hand up again. Palesa, when I say you're getting rid of the 1, if you have a look here, you've got minus 1 plus 1, haven't you? That's what gets rid of the 1 because that's an additive inverse, isn't it? So it's like if you've got minus x plus x, it adds up to 0. Minus 1 plus 1, it adds up to 0. Okay, does that make sense, Palesa? So it's just through an additive inverse. That's how you're getting rid of the 1.
Tamia, you should be able to talk to us though, because you are connected to audio. So you can try now. You can unmute yourself on your side.
Okay. All right, Palesa.
You just have to talk, Tamia. You're unmuted, but then now you need to talk. If you can hear us, however, it means that there's something wrong with your settings on the device that you are using. Just try to play with your volumes up and down. I'm not sure. Or maybe it's your mic that is giving you problems. I'm not sure. Otherwise, you can type your question on the chat. We'll be on the watch.
Yeah, absolutely. Anyway, I hope you guys have taken screenshots. I'm going to move on now. If there are any questions later, then we can certainly come back to this question if there is time. Okay, so here is another question for you. This one is not as difficult as the one that I gave you for homework. All right. What I would like you to try and do is see if you can attempt this. Let's try and do it together. All right. So I'm going to ask questions. I'm going to ask you what you think we should do, and then you guys can respond and we can kind of work through it together. I have got some for you to try on your own, but originally I wanted to do this one together with you. Okay, so if we have a look at the left-hand side, we can see we've got cos 2a at the top, and we can see we've got cos 2a at the bottom, right? So let's start with the left-hand side. Okay, on the left-hand side, we have got 1 plus cos 2a, and at the bottom, we've got cos 2a. Now, we cannot cancel. I cannot cancel the 2a, the cos 2a at the top with the cos 2a at the bottom, because then I would be breaking a mathematical rule. I can't cancel terms. I can only cancel factors. All right. Again, I want to get rid of the 1, Palesa. I want to get rid of the 1. So how can I rewrite cos 2a so that the 1 goes away? What can I do? Any suggestions, Matrix? How can I rewrite cos 2a in the numerator so that I get rid of the 1? Yes, Amahle, go for it.
You use the double angle that says 2 times cos squared a minus 1.
There we go. Okay, so at the top,
Thank
I'm going to
you.
write, well done, 1 plus 2 cos squared a minus 1. all over cos 2a. So now again, I've got this additive inverse. The 1 minus 1 means that I no longer have 1 in the numerator. I've just got 2 cos squared a over cos 2a. So now I'm looking at this and I'm thinking I'm stuck. I can't cancel cos a with cos 2a because it's not the same thing. If I rewrite cos 2a, I'm going to go back to a situation where I've got a binomial in the denominator, but I can't factorize because I don't have a trinomial, I don't have difference of squares, etc., etc. So when you get to a situation like this, chances are you need to work with the right-hand side as well. Okay. The third double angle. All right, Lebogang, West Coast, sorry, can you please repeat the second step? Okay, so all we've done is rewrite cos 2a as 2 cos squared a minus 1, so that the 1 at the front and the minus 1 at the end cancel each other out. They add up to 0. So we're just left with 2 cos squared a. All right, as I was saying, if you are now stuck, chances are you need to go and work with the right-hand side. So you've got to work with the left and the right separately from one another. So let's go up and go and have a look. Tan 2a over tan a. So I'm going to write that down. And now, again, I'm putting the difficult question to you guys. What are we going to do with tan 2a? What are we going to do with tan 2a matrix? Sandisiwe, go for it.
I think that we can use tan 2a as cos 2a and sine 2a, if that makes sense, ma'am.
It does. It does. So you just got to be careful which one you put at the top and which one you put at the bottom. There we go. And Nhlanhla and Nkateko, you're correct. We do, Amahle. That's exactly what we do. Well done, guys. So we say sine 2a over cos 2a. Brilliant. And now what I'm going to do is, instead of writing it as a complex fraction, I'm just going to say divided by tan a here on the side. The other thing that I could do if I wanted at this point is I could write this as sine a over cos a. All right. Which I'll do in my next step. So sine 2a I can only write as 2 sine a cos a. Because I have a cos 2a in the denominator over here, I'm not going to do anything with this cos 2a over here. All right. I'm going to leave it as cos 2a for the minute. So tan a is sine a over cos a. So now this is why it's so important to know how to be able to work with fractions. When we are dividing fractions, Lara E, because that is what the question asked of us. Okay, so there's the question again. On the right-hand side, we had tan 2a divided by tan a. Okay, so rather than writing sine 2a over cos 2a all over tan a, I'm writing the divide by tan a next to it. Okay, because it just makes understanding the next step so much easier. How do we divide fractions, Matrix? What's the rule for dividing fractions? Sandisiwe, you hot off the mark again. Go for it. What's the rule for dividing fractions?
When dividing fractions, then we know that the numerator will go to the denominator and vice versa, to say.
That's it. Okay, so I've got to change the divide into a times. And then I can put what was at the top at the bottom and what was at the bottom at the top. So cos a goes to the top and sine a goes to the bottom. So I'm doing tip and times or keep flip change, whatever it is that you've been taught. Again, there are no pluses and minuses in my numerators or denominators. I only have multiplying and dividing, so I am allowed to cancel down. I can divide sine A with sine A, and that's the only dividing that I can do so far. Okay, and now if you have a look, if you collect what's left over, you've got what you've got on the right-hand side, because you've got 2 cos A times cos A, so that gives you 2 cos squared A, and in the denominator, you've got cos 2A. All right, and now you can conclude, therefore, the left-hand side equals the right-hand side, just like so. Okay, there we go. Yes, keep flip change or tip and times, absolutely. Okay, any questions regarding this one? Sandisi, we go for it.
Ma'am, the 10, starting from the part where we have 10 beta, why do we divide with the 10 beta?
Because that was part of our question. Okay, so if you have a look here at the right-hand side, look here at the right-hand side, you can see tan 2a was being divided by tan a. Remember, over means divide. Okay.
Now I understand. Thank you.
Okay, no problem. Okay, so Laura E., if you didn't know to work with both sides, is there any other way to work this out and maybe get a few marks? In this particular case, Laura, that's a good question. In this particular case, often there is, Laura, but in this particular question, I don't think so. And I think the reason for that is because what this simplifies to. So you've got this 2 cos squared A at the top. Now, there's 3 ways that you can write cos 2a, but it doesn't matter which one of the 3 ways you write it. You're not going to be able to go any further. So let's say you decide to write it as 2 cos squared a minus 1. You're still stuck, aren't you? There's nothing else that you can do here. You can't cancel what's at the top, the 2 cos squared a with the 2 cos squared a at the bottom, because then you'd be breaking mathematical rules. You'd be canceling over a minus sign. Okay, so rewriting your denominator doesn't allow you to simplify any further. All right, so what else could we possibly do here? No, I mean, no, I'm just trying to think if you wrote cos squared A as 1 minus sine squared A, but even then, you're still not going to be able to simplify or factorize. Okay, so this is the sort of situation where you would know that you'd need to use both sides. You'd eventually get to a point where you cannot simplify any further. So now you go and have a look. Also, if you have a look at the right-hand side, you've got tan 2a and tan a. So you can do something with that. It's not like you've got sine x plus cos x. There's nothing that you can do with sine x plus cos x. But at least with tan 2a and over tan a, you can use your tan identity and you know that you can manipulate it further. So those are the hints or the clues that you could use to know that you've got to work with both sides. Leanne, the numerator. Okay, we started with 1 plus cos 2a, Leanne, and then we rewrote cos 2a as 2 cos squared a minus 1. So the 1 minus 1 means that the 1 is not there anymore. Okay. All right. How are you feeling so far? Do you feel as though this is extending you? Are you thinking about things that you maybe didn't think about before? How are you feeling? You can just pop something into the chat. Hopeful, confused, still shaky, that's okay. Lebogang. Okay, all right, Laura. Well, I'm sorry you only found us now. Definitely. But you know what? You can stay here with us before finals. We're going to be doing lots and lots and lots and lots of revision and lessons, etc., etc.
Yep.
Okay.
And you will pass, definitely, with good flying colors.
Okay. Thank you. Cool. Thank you so much. In Sansa, yes. Sometimes it is and sometimes it isn't. That's fine, Faith. Okay, even if it's just one step at a time, it doesn't matter. It's not a problem. Okay, no one's judging you. We're only here to help you. Thank you for your honesty. That really means a lot to me. In Santla, sometimes there are other ways that we can do things and sometimes there aren't. So in this particular case, there is nothing else that we could do with our 2 cos squared a at the top over cos 2a at the bottom. Over here, in this previous question, I didn't mention it at the time, but yes, there's another way in which we could approach this particular question. So if we wanted to, I was thinking about it just now, we could have rewritten this one over here. So when we've got our denominator here, there's a different way that we could have worked with the denominator. So once we get it to this point over here, there's something else that we could do with the denominator. Not nothing else we can do with the numerator, but as far as the denominator is concerned, we could do something else there. All right. Which, if you wanted me to show you, I can. But sometimes there will be things that you can do, and then other times there won't be anything. It just literally depends on the question that you've got. Okay. Okay. So Laura, I will come back and answer your question before the end of the lesson today. I'm going to move on, but we'll come back and I'll talk about that just now. Okay. All right, let's have a look at the next question. So again, I've picked something that is a bit more challenging. All right. I don't want you guys to be scared. Nothing bad is going to happen if you do this and you get it wrong. Okay. Give this one a try. All right, so you've got sine theta plus sine 2 theta in the numerator, and at the bottom you've got 1 plus cos theta plus cos 2 theta. The things that we have spoken about in the first question and the second question should assist you working with the left-hand side. If you are simplifying the left to get tan theta on the right, chances are you're going to end up with sine theta over cos theta. That's where you're headed to. If you can get sine theta over cos theta, then you've done it. All right, so give this one a try. I'm going to give you 5 minutes or so, and then we will reconvene and discuss. Okay, remember, Yolanda and I are here to help you. So if you do need any extra assistance, then just call on us. The formulae are there on the right-hand side for you. Okay, all right. Here we go, people. Ready, steady, go.
Hello, ma'am.
Hi, Santisi, where are you stuck? Oh, that's good, Nhlanhla.
Yeah, I'm on the second step, ma'am, and I got 2 sine theta on the numerator, as well as 1 plus cos theta on the denominator, plus cos theta minus sine theta. I used the second double angle formulae for the cos 2 theta, ma'am.
Okay, so that's correct. That's exactly what you should have done. So you should have rewritten cos 2 theta as 2 cos squared theta minus 1. So now you need to factorize. You've got to factorize the top and you've got to factorize the bottom. Look for highest common factors that you can take out.
Oh, yes, ma'am.
Okay, I'm going to do the question now. I see there's a lot of people. Now, look how quickly you guys are saying done. That to me is really encouraging. Okay, so what we've just spoken about has obviously helped a lot of you or a few of you in order to be able to answer this question. There we go. There's another done. Those of you that are not done, wow, okay. Don't feel bad. These are difficult. They are meant to be difficult. All right, so you guys certainly did that fast. I've been watching the time here. That was only 3 minutes if you're saying done already. Okay, which is super, super encouraging. Nice, guys. Okay. So depending on where you are, let's just have a look at how, because we should all have at least done the first step in this particular case question. Well done, Busisiwe. That's great. Okay, so on the left-hand side, we've got sine theta plus sine 2 theta. And in the denominator, we've got our 1 plus cos theta plus cos 2 theta. So the only thing that we can do in the numerator is use our double angle formula. So we're going to write that as 2 sine theta cos theta. That gets us 1 mark at least. And at the bottom, remember, we want to try and get rid of the 1. So 1 plus cos theta plus 2 cos squared theta minus 1 gets rid of the ones at the bottom. Okay, so everybody should have been able to do this. If you can do this, this is at least 2 marks. 1 mark for the identity at the top and 1 mark for the identity at the bottom. 2 out of 5 is better than 0 out of 5. Okay, let's see if we can get more marks than just 2. So everybody should have been able to get there. We can see that now at the top, we can take out sine theta. Okay, so if I take out sine theta at the top, that's going to leave me with 1 plus 2 cos theta in brackets. Remember at the bottom, the ones are gone. I've just got cos theta plus 2 cos squared theta. So at the bottom, I can also take out cos theta. That's going to leave me with 1 plus 2 cos theta at the bottom. All right, now, I don't know if I've lost anybody at this point, but I'm happy to come back and explain that to you again. Now you can cancel. Okay, remember we can't cancel over plus and minus signs. Plus and minus signs means we have to factorize the bracket at the top with the bracket at the bottom. That leaves us with sine theta over cos theta. And there we go. We've got our tan theta, which was on the right-hand side. So again, we would get another mark over there. Okay, so something like this would be out of 4. 1 mark for our identity at the top, our identity at the bottom, another mark for factorizing, and the last mark for getting to sine theta over cos theta correctly. Okay, so give me a thumbs up. Did you get this right? Thumbs down if you went wrong somewhere or it didn't go as planned. That's great. Okay. In Kateko, don't be discouraged. These are not easy. Okay, but remember, well done, everybody who's got a thumbs up and is feeling confident. 2 steps, that's fine. Okay, 2 out of 4 is 50%. Okay, there's nothing wrong with that to start off with. Okay, good, well done. I'm really, really pleased for you. Steppy so good, very nice. Okay, any questions before I move on? Got 3 out of 4. That's great, Pelea. So that's 75%. Tamia, no. Okay, remember these lessons are being recorded. You can come back and watch this again if you need to. Okay. All right, so let's move on and let's have a look at some other questions. Okay, so the first one that I want to focus on is question H. Okay, now, Amahle, I'm pretty sure it was you last lesson. Okay, so I'm going to go back. Ubaid, it's okay. All right, it's a work in progress. Amahle, do you remember, this was our last
Yes, ma'am.
lesson on do you remember on Tuesday, you said to me this was the only one that you were going to get right? Do you remember you picked A, didn't you?
Yes.
You picked A. Do you remember I gave you cos squared theta plus sine squared theta squared? And you said, yeah, we were going to do question A. Now, the reason why I'm
Yes.
calling on you, Amahle, is
Mm.
because when you squared this binomial, you told me beautifully cos squared theta plus 2 sine theta cos theta plus sine squared theta. Do you remember that?
Yes.
Okay. All right. So you are doing exactly the same thing over here in H. Don't be put off by the angle. All right. The
Okay, so
bracket,
are we creating an equation like
you're not
like we did? Not an equation, a quadratic, sorry. Like the one
exactly.
on the top.
Exactly. So remember over here, when you squared your binomial, you ended up with cos squared theta plus 2 sine theta cos theta plus sine squared theta. It is exactly the same thing. It's just the angle that's different. But just like before, you didn't square the angle, you squared the ratio. So use the angle is now theta over 2. So what? Okay, just treat it like it's theta or like it's A or whatever the case is. All right, so I want you guys to try question H. I'm trying to show you how H is similar to what you saw in A on Tuesday. Does that make sense, Amahle?
Yes, it does, ma'am. Thank you.
Okay, all right, cool. All right, so off you go, guys. Left-hand side, you're squaring the binomial. Right, so I'm just going to write it on the page. I'm not doing the question for you until we mark it, okay? So just to help those of you, I'm just using X's and Y's. Okay, so the pink is your hint. If you catch my hint.
You guys are doing really well though. Well
They are.
done.
They are. They are. So to see where you stuck.
I have 2 brackets at the start, ma'am. So as the hint you gave us. So now we're multiplying both of those brackets. Now the thing
Absolutely.
that's
You're doing FOIL. Okay.
yes, ma'am. And
Okay.
now the thing that's confusing me is the denominators are 2's. So now I just added the denominators. I don't know if I'm correct or wrong.
No. So remember, you're not working with the angle. Okay, you're working with the ratio. The ratio is cos theta over 2. Okay, so the denominator of 2 belongs to the angle. It doesn't belong to the ratio. So in other words, if you have got cos let's move my mouse. The rest of you carry on, unless of course you're very, very stuck. Oh, what am I doing here? I'm going mad. So, Sandisiwe, when you were doing FOIL,
Yes, ma'am.
you would end up with cos theta over 2 times cos theta over 2. That is going to give you cos squared theta over 2. Then when you multiply your outers together, that is going to give you cos theta over 2 plus, sorry,
Cos theta over 2 and sine
sine
theta.
theta over 2.
Okay.
Good, good. And then when you do your inners, you're going to end up with the same thing. So sine theta over 2, cos theta over 2. And then your last term would be sine squared
Sine
theta over
theta
2.
over
So now your two like terms are the ones that are in the middle. Your two like terms are the ones that are in the middle. So now you've got cos squared theta over 2. So now just like when you add xy and xy, you've got 2xy. When you add cos theta over 2 sine theta over 2 to sine theta over 2 cos theta over 2, you've got 2 sine theta over 2 cos theta over 2. Okay. All right. Plus sine squared theta over 2. Okay, that's what you should have. All right, so you're not adding the angles. No, Amatle, there's no error in the question. Okay, so sorry, guys. So your identities, let me just drag these down and pop them over here. Okay. I don't know if those of you that were stuck were watching what I was doing with Sandisiwe here on the right-hand side. Okay. Let's just have a look at what you guys are saying in the chat. So Rafulue's done, Tepiso's done, Mamelo's done, Capano's done. Oh, okay. Oh, wow, there's lots of dones. Okay, so Amatle, no, there's no error in the question. Laura's stuck. Linda wanted to see the... Okay. All right. So just going through what I was saying to Sandisiwe one more time. Okay, and then we can just check that you guys have got this. Okay, it really is identical pretty much to question A that we did on Tuesday. Okay, so when you are squaring a binomial, you are multiplying the binomial by itself. you're using FOIL. So firsts gives us cos squared theta over 2. Outers gives us, and it doesn't matter the order in which you write our factors, whether I write cos theta over 2 sine theta over 2 or sine theta over 2 cos theta over 2, it's the same thing. Just like xy and yx are the same thing. They're like terms. So you've got sine theta over 2 cos theta over 2. Inners, you've got sine theta over 2 cos theta over 2. Lasts, oh, excuse me, sorry guys, I hope I didn't sneeze right in your ears. Plus your lasts would give you sine squared theta over 2. Okay, does that make sense to everybody? Okay, so we've just done FOIL. Okay, remember when we do FOIL, our two terms in the middle are like terms that we can combine. Same story here. So now we've got cos squared theta over 2 plus 2 sine theta over 2 cos theta over 2 plus sine squared theta over 2. Now, something special happens here. Cos squared theta over 2 plus sine squared theta over 2. That's an identity, isn't it? Okay, so this is where you got stuck. All right. So cos squared theta over 2 plus sine squared theta over 2, Nkateko, is your square identity. Exactly, Nhlanhla. That equals 1. Good. All right, so you see how well you've got to know your grade 11 identities. Okay, so they come up all the time. So that's where this one comes from. Cos squared theta over 2 plus sine squared theta over 2 is 1. And now I'm going to bring down the middle term plus 2 sine theta over 2 cos theta over 2. So that is this. It's 2 sine A cos A. It is your cosine double angle. So now what we're going to do with it is we're going to write it like that as a double angle. Okay, so plus sine. It is the double angle of theta over 2. All right, and this 2 is in the numerator. That 2 is in the denominator. And that's how you get sine theta. Okay. All right. Any quick questions? Pleasure and Kateko. I might go for it.
Ma'am, is there no other way of writing the information in the square brackets?
No. No,
Okay.
because when you square a binomial, there's nothing else that you can do with it.
Okay,
Okay,
because
so
I'm unfamiliar with that notation, so it's I'm finding it a little bit hard to understand, but I get
which
it.
notation? What notation?
The 2 times the theta over 2 in the square brackets.
Oh, okay, all right. So
Yeah.
in other words, what I'm doing is this, okay? If you've got 2 sine theta cos theta, that is a sine double angle.
Yes.
That's all I'm doing.
Okay.
Okay, so what I'm doing here is I'm just writing it as I'm going from the right-hand side of your identity. So in other words, this side over here where it's written as 2 sine A cos A, it's been expanded. I am now doing the opposite of the expansion. When I go from here to there, it's the opposite of the expanding.
Oh, all right, I see it now.
Does that make sense to you now? That's
Yes,
what I'm
that
doing.
does
I'm
make
doing
sense.
the opposite of the expanding.
Okay, thank you
Okay.
so much.
No problem. It's a pleasure. There you go, Lesejo. Okay, so if you want to, Aaron, I see you've got a question there. You can always email me at lee@watobe.com and I can help you. Oh, sorry, I'm emailing the wrong person here. Sorry, it needs to be everyone. So this is my email address. Okay, and then Laura, at this stage of Watobe, we do not offer, unfortunately, we do not offer notes per se. All right, what you'd have to do is come back and watch the videos again. But I believe this is something that they are working on, to sort of try and yeah, offer you guys something a little bit more. But I mean, I'm not the one that's directly involved in those decisions. Okay, you will also have access to last year's videos. Okay, Laura. All right, so now if you guys want a few more to try, just a couple that okay, we've already done I. Here's question J. It looks very intimidating and very difficult, but I promise you it actually isn't. So if you want to, Intlantla, other people, you're welcome to try question J. Maybe I can do that at the start of the next course as well, if you want to. Okay, so have a look at that one too.